Hello and welcome to C++ Weekly. I'm your host, Jason Turner. In this episode, I'm going to talk about the humble modulus operator, or modulo. Honestly, I'm not sure which way that's actually supposed to be said. Now, as always, I am available for code reviews and on-site training, and be sure to check out the links in this video description for information about this particular episode and information about the rest of the channel and contacting me. Now, the humble modulo, this percent sign, if you will. We like to think that we know what this does. It returns the remainder of two integers being divided. Sounds pretty straightforward, right? But the question is, what happens when the divisor is negative? What happens when the dividend is negative? Which, if either sign, is kept? And if we go to our good friend Wikipedia, we can see Wikipedia says that the modulo operation returns the remainder or the signed remainder of a division. And this episode is not going to be very long. I'm just going to try to show you that there are apparently several different ways of interpreting this. The rules all come down to whether you round down or truncate the result of the integer, and then it comes down to which sign has been kept. So there's graphs here, which I find to be terribly unuseful, but I do have a bunch of examples in different programming languages. The key takeaway is that of common programming languages, we have three well-used different versions. So this is C++ Weekly, and we're generally talking about truncated when we're talking about C, C++, other languages in this family. But we also have floored, used by several different programming languages, and this interesting one called Euclidean. But that's basically what we're looking at: truncated, floored, and Euclidean. There are rounded ones, but those come into effect more when we're talking about floating point remainder, and I'm not going to get into that at all. I'm talking about integer division, integer remainders today. So if you've been paying any attention, you probably have observed that I have been covering some information about Python lately on the channel. And Python uses floored, which is different from the truncated that's used by C++, which is what originally brought this issue to my attention. And so we're going to look at what the actual results of these different truncations, floored and Euclidean, looks like in three relatively common languages today. Now you'll see that floored and truncated are by far the most widely used in programming. So these examples again are going to be linked to from the video description, but what I have here is a C++ example that is calling the built-in modulo operator. And you can look through and see all the different things that might happen here. If we have -8 divided by 4, what is the remainder? It is 0. That is pretty straightforward. If we have -7 divided by 4, is the answer -3 or is it +3? If we have -7 divided by -4, how is the remainder -3 when it's the same here, right? So there's all these different questions, ways of looking at it, but this is just what it does. If we go over here to the Dart version, we can see that regardless of sign, Dart always returns a positive remainder, and this is the Euclidean version that Dart has. So if we have -7 divided by 4, we have 1 as the remainder, where if we have 7 divided by 4, we get 3 as the remainder. And scrolling over here to the Python version, we see that if the divisor is positive, then we always get a positive result. If the divisor is negative, then we get a negative result. Now, I did see a comment on Twitter when I was discussing this, that the Python version, the floored one, is the only one that has an actual use case. And I will actually demonstrate this use case because it is directly relevant to the Game of Life simulator from a few episodes ago. If I have an index into an array, and I know that the array is size 4, then I can use a floored modulus to always do perfect wraparound. So I will demonstrate. If I put in index 0 and I ask what the remainder is, with 4, then it's 0. So if I put in 0, I'm going to get index 0. If I put in 1, I'm going to get index 1, 2, 3, 4, etc. Now, as soon as I get to index 4 on a 0 indexed array, if I do a modulus 4 against 4, then I'm going to get a remainder of 0. And that's exactly what I wanted. This causes my array to wrap around if that was the goal. And for an infinite playfield, wrapping playfield for the Game of Life, this is exactly what I want. And working backward, if I put in a -1 and ask what the remainder is when divided by 4, then I'm going to get 3. And that takes me back around to the right side edge. So even if someone were to put in -5, I'm going to keep perfectly wrapping around. And the floored modulus is great for that particular use case. Honestly, I have never worked with a programming language that used Euclidean modulus, so I don't really know what the use case is for this one. And the C and C++ built-in one doesn't give us quite that same logic. It works okay when we're moving forward, but as soon as we try to put in a negative index into this wraparound logic idea, -1 divided by 4, what is the remainder? -1, that doesn't actually help me in any situation. So I've been scrolled down here. I do have, in the C++ version specifically, implementations for each of these. The Euclidean, floored. I have an alternate implementation of the floored. This is the technical definition. This is the definition that works quite well in C without needing to call any standard library functions. And I have the truncated version. And a lot of them come down to actually doing like a floating point division and then simply truncating that or calling standard floor so that we get that exact behavior that we want. And otherwise it's pretty straightforward. The Euclidean takes into account the absolute value of the divisor. And if you wanted to play with this, then you can easily come in here and just pass a different function to my run function, and it will run it and show you the Euclidean, floored, or built-in options as desired. So make sure, again, you check out that link. So that is the point. The point is that modulus is not nearly as simple as you would have hoped it was. And if you're trying to port algorithms between different programming languages, you, like me, will end up with some rather unexpected behavior. Feel free to come back and read this Wikipedia article on why all of these different versions exist and what the arguments are for and against them. Hopefully this was an interesting episode of C++ Weekly that at least caught your attention for a few minutes, and I will see you next week.